Hi everyone, welcome back to my channel, and today in this video we are going to study about the Saga pattern. So in the last two videos we have covered about the two-phase commit and the three-phase commit. These two topics are the starting block of to understand the distributed systems. And now we are studying about the Saga pattern. That is something that we actually use in the production, that is actually used in the industry to do the distributed transactions into the microservices architecture. So first of all, let's talk about the definition. A saga is a sequence of local transactions where each step has a compensating action to undo it if the overall transactions fail. Okay, so I want to tell you the like a simple meaning of the saga pattern here, that every operation we should have a undo operation. Okay, let's say if we move forward one step, then we should have a button by which we can just go back one step. This is what I'm trying to say. Like if we go forward, then we should have a functionality of go back as well. Okay, this is how the saga patterns one work. I'll give you one simple example. Sorry for this dumb example, but I'll give you a better example here. We have three services: order service, inventory service, and the process payment service. The same example that we have used in our three-phase commit and the two-phase commit. Now what we are going to do is that, suppose that we are going to do a transaction. Now the request again first of all land to the coordinator. In all the three things, the first of all in the two-phase commit and the three-phase commit, we were having this coordinator, and at the end here also I mentioned that the con here, if you'll able to see that this, of course if we have a coordinator, then if the coordinator fails, everything fails. So of course in the saga pattern there is going to be a problem of this con, that there is going to be a single point of failure if the coordinator fails. Okay, this saga pattern is divided into two parts. First is saga orchestration and the saga choreography. Okay, this is the saga choreography, we'll study it. So now we are studying about the saga orchestration. So in the saga orchestration, what is going to happen, that we have again this coordinator. In this coordinator, what is going to happen, all the user will send the request, the coordinator will receive it, or we can say the central entity will receive it. After that it will send the request to the order service, inventory service, and the payment service. Okay, now coordinator sends the request. So previously we have this reader phase, commit phase. We don't have anything in the saga pattern. We directly send the request to order service to commit. It means that we send all the metadata to do the transaction, and the order service will say that I'll do the transaction, and it will say yes, I've done the transaction. So order service will do the transaction, mark success. Let's say again inventory service will do the transaction, mark success, and let's say payment service also do the transaction and reverts success. Then it is a very good scenario. All the three services we send the request and we get back the success. Okay, but now there is a scenario, for example after this order service, the inventory service, after that what happens, that payment service, when we send the request and the commit fails, in that situation what is going to happen, we'll mark it as fail. Okay, because of course the transaction didn't happen because of this commit fails in the payment service. Maybe the payment service is down. There can be a situation that because of some reason this transaction didn't happen. In that case we have a functionality. Okay, we have to like custom logic we have to write, that in the coordinator, if we got fail request from the payment service, then we'll send the request to inventory service to revert, in the order service to revert. Okay, what we do actually, we have those entry into our order service and the inventory service marked as success. We'll mark them as revert. Okay, or we can just simply mark them as revert because the payment has been failed. This is something that we do in our orchestration pattern in saga. Now think of it, if the coordinator fails, we have this single point of failure, and this is the problem one. Okay, second problem is that it is very tightly coupled. Okay, everything is dependent on this coordinator as well. The coordinator is managing every single thing. There is one more problem that I wanted to mention. I missed it here in the cons, but I wanted to mention here that, think of it, that every single time, let's say there are going to be 8 services. Okay, let's say when there are going to be 8 services, let's say after transaction failed at seventh service, so we have to send 6 more requests, okay, to all the services, so that this transaction can be rolled back. Okay, first let's, for example, there we have 8 services and we send the request to all the services. Seventh request got failed, and Now we have to send the request to 6 services, the like all the services behind that service to roll back. So like too many requests are involved, too much tight coupling. Okay, think of it. Like we are just mentioning 3 services, then how we are getting so many arrows. But like think of it that we have, let's say, 8 or 9 services in one single transaction. Like it is going to be so much cluttered. It can create a problem. So this is a problem with the Saga orchestration. Okay, but still, if we have like many services running of this coordinator, okay, we can handle this single point of failure. But there is a like chance of a single point of failure in the Saga orchestration. That is what I'm trying to say. But now let's move to the second thing, that is known as the Saga choreography. This is something that we actually use in the production, that is very quite a common pattern. Now what is going to happen, the request is so here you will see this diagram is like very different from the 2 phase commit, 3 phase commit, and to our Saga pattern orchestration. Here we don't have any coordinator service. Request will directly come to the order service. Order service will after doing the order service will send the request to the inventory service. Inventory service will mark success. Order service will send the request to the payment service. Payment service will mark request, and order service will say yes, the order is completed. This is a very good scenario that everything worked well. But think of it now. Here everything is happening on the basis of the event. Now what happened when the request come, order service will do its own thing, like order service will do the transaction. After that it will send an event to the inventory service, yes, please do the transaction, and it will send the event to the payment service as well. Okay, so order service send 2 events, one event to inventory service and one event to the payment service. Now again the custom logic comes. What is going to be the custom logic says, let's say the payment fails. Okay, we get this payment fails. Now in that case, when we have this payment fail, it means that the payment didn't happen. Okay, now we are sure that payment didn't happen. Now when we receive that order service, that payment failed, now what we are going to do, we are going to send an event to the inventory service again, that please revert. Okay, so this is the event that we send, please revert that transaction. Okay, please revert that inventory, and we will send one more event to order service itself. Okay, we'll again send the one more event to the order service itself, that please revert that order as well, because payment has failed. Okay, everything is working on an event here, so it is going to be an asynchronous operation, it is not in sync. Okay, because order services send the event of success, and when the payment service return the failed operation, then we send the event to the inventory service. We can send this event with the help of an API. Okay, we can make it synchronous with the help of an API. We can use a Kafka as well, that whenever the inventory service will get this revert event with the help of any Kafka, SQS, or anything, okay, it can be asynchronous, it can be synchronous, but usually think of it that it is going to be asynchronous. So there can be a certain time, okay, in this Saga or choreography as well, that there is going to be inconsistency, but the system will become consistent because everything is happening with the help of events. There are going to be queues involved. Okay, so this makes system very scalable. Secondly, there is no coordinator service. Okay, if there is no coordinator service, now we know very well that there is no single point of failure. And I also told you that everything is happening with the help of events. So think of it that if everything is happening with the help of events, now what will happen if, let's say, if the inventory service is down, okay, in that case everything is stored into the Kafka or in the SQS. When the inventory service will come up, okay, again we can mark those transactions as reverted. Okay, so this will provide you more flexibility, like more safety to the system. Transactions are going to be more safer. That's why we use Saga choreography in our production. Okay, no single point of failure, everything is happening with the help of the events. Okay, I will read this pros and cons for you. That first of all, that there is no central coordination, highly decoupled. Okay, we are not dependent on one coordinator. Everything is talking to everything. Order service talking to inventory service, payment service, and there can be a situation that payment service can talk to the inventory service. We can make any custom logic here. Good for event-driven architecture. That's what we have discussed. That we can use Kafka, SQS, anything. But very scalable. But now comes to the cons. Okay, everything will come with the pros and the cons. So of course, it is very hard to understand. Okay, very tough workflow. We have to maintain a lot of documentation. Let's say if once more service added, let's say one more service added, let's say that we make one more service here, let's say for example notification service. Okay, again, now what we have to do, like we have to think of it like with this notification service, to which service we have to connect it with. Like, should we connect with the payment service, to the order service, or to the our inventory service? So we have to think of it. We have to change our diagrams, we have to change our workflows if the new services are adding, and like if one service is leaving, anything can happen. So this is a problem with our Saga choreography pattern. It's very hard to debug. Let's say, for example, let's say one event is missing, like one of the event is missing, any service is down. It's hard to debug. Where is the transaction stuck? And everything is happening in the event, so the transactions can take time as well. Okay, everything is not going to consistent, but it the transactions can take time as well. So it is very hard to debug here. Event chain can become complex, that we have discussed, that if one more service we add, like we are not sure like how we are going to make a new network, like should we send the request from the payment service or from the order service. We have to make this whole system. Okay, so the chain can be complex. Okay, it's very hard to add a new service. Hard, like if one service is leaving payment service, then again it is very hard, difficult to debug, and hard workflow. But I'm telling you that this is something that we use in our production, because it is scalable. It use Kafka. It is like there is not going to be a single point of failure here. Every services can communicate with and every other service. There are events involved, so it is better than everything that we have studied. It is better than two-phase commit. It is better than three-phase commit. It is better than Saga orchestration. So this is something that we use, Saga choreography, in our production, that helps system scale and helps to do distributed transaction in our microservices architecture. So this is it all for the this is all for the video, and we'll meet into our next video. So thank you for watching me, and bye bye.